Hello, today I'm gonna test two products, CAMWorks and SolidCAM. From the beginning, as you may know, I will not talk here about the prices. For me, these are two CAM products and I will show you how it is, how can I machine this part in SolidCAM and how can I machine the part in CAMWorks. Of course, I'm working in CAMWorks right now, so I will move a little bit quick in CAMWorks and a little bit slow in SolidCAM. But in the end of this video, you will have the ability to see the difference between the workflow in SolidCAM and the workflow in CAMWorks. You will see a few options for 2.5 milling mainly, both in CAMWorks and SolidCAM, and I think you will have all the information you need to decide which is the best for you. So, SolidCAM works under SolidCAM or under a SolidWorks license. So first of all, let's start a new milling CAM project. This is a nice function, create CAM part external or internal. I will leave it to internal. So mainly the workflow in SolidCAM is the same for milling and I think also for turning. From the beginning, you will need to define the machine with the post attached, the coordinate system, the stock, and the target part. So for the coordinate system, I have here some good options. I will select the face, then define the origin. It's here. The X direction is this one, and the Y direction is this one. I will leave it here. I have the ability to flip around the both axes. Click OK. From the beginning I can define levels, but I will leave it the default values. And now the target part is already checked by SolidCAM. And now to define the stock. To define the stock, you have here four options: box, extruded boundary, 3D model, cylinder for turning and not and mill turn, let's say, and STL file. I will leave it to box, select the part, and I have here some default values. Okay, I will leave the default values because I want to move a little bit quick. So from the beginning, the first operation I will made it's a face. When you select a face in SolidCAM, the geometry is already selected for you from the top face of the part to the top face of the stock. The tool, I will create a new face mill tool. Okay, the levels, the technology. You will have here a preview of the operation. Let's leave it that way. One path on the Z direction, and this is the face mill. Okay, now I will start with the roughing of these three pockets. New operation, I will select pocket, select the geometry, you select a chain, and then SolidCAM recognize all the depth of the pocket. This is a nice feature. Then the tool, I will select a new end mill tool, diameter 12. Okay, let's say for the tool I can also of course define the feeds and speeds, the coolant, if I have different tool change position, and now for the levels. Okay, so right now I have an upper level and the pocket depth automatically recognized by SolidCAM, and stepping down I will choose 2 millimeter. As a technology, I have here some options. It's like a pattern. I will leave it to hatch. and keep the cutting direction, one way or zigzag. Of course, linking, ramping, links between passes, between separate areas through, motion control, and miscellaneous parameters. I will calculate. This is my roughing operation. Save and exit. Okay, so I will copy this operation, paste it one or two on the second one. I will edit, of course, the geometry, select the other pocket, calculate. Let's change the technology to contour to have another, it's just like pocket in, pocket out from other products. Okay, the last pocket will have, let's say, hatch and finish. You have the ability here to have a finish path on the wall, on the floor, and let's calculate. But I need to change, of course, the geometry. The geometry will be this one. Calculate, save and exit. Okay, so I have the face mill, the roughing of all pockets, new milling operation. Let's try the profile operation with another tool. The geometry will be this first pocket. The tool, I will choose another tool. Let's say N mill, diameter 10. Okay. Levels, profile depth, I will need only one pad. Calculate, save and exit. To hide all the, I will hide all the other operations in order for you to see only the profile operation. I will open again because I want to look at technology. I have here the ability to modify the tool side. Okay, if I want to left, right, or center. Okay, what the depth type, but I want to see also the lead in and lead out. Okay, lead in I want to be normal, same as lead out. Calculate. Okay, perpendicular lead in, save and exit. Of course, I will do the same with the other pockets. Copy, paste, delete, modify the geometry, the second pocket. Okay, let's look at technology. Let's check the tool side. For this profile it's wrong, so I need to change it, calculate it, and let's use another lead in. Let's try the arc lead in. Okay, same as lead out, it's same as lead in. Yeah, okay. Save and exit. And the last pocket is this one. I will of course change the contour. Okay, but if I want to choose from this geometry edit the direction of the profile, because I have here an error. I cannot find it, but it's no problem. Technology. Let's check the technology. Change from left to right. Calculate. Okay, save and exit. For the drilling of this counterbore hole, I will use the hole wizard process because I already have here a technology for counterbore hole. just select the counter bore, click OK, and you will have a spot drill, a drill, a profile of the bore diameter, the chamfer, and the chamfer for the upper side and the chamfer for the lower side. Okay. So the only thing it is left for me right now is to do something on the perimeter of this part. So for this I will insert also a profile operation with this geometry. It's okay. Let's look at the tool. I will select, let's look here. I have diameter. I will choose another end mill with diameter 20. Okay, and the levels, only one, but I need more paths for, because right now I only have one path, but the same mistake I did the same mistake. I don't know the technology, geometry, modify the tool size from left to right. Okay, let's look here, compensation on finish passes, depth type constant, and for the rough I have here the step down pass. Let's put 5 millimeters, and here link for the lead in, a normal lead in, and same for lead out. Okay, calculate again, save and exit. So right now I'm ready to post-process this part, but before post-processing, of course, I need to run a simulation. I have here different options. I will use the solid verify simulation. Let's play. So the facing, the roughing, different patterns for the rough, all three pockets, then the finishing. Right now I have a clash between the holder and the machine stock. I will continue. Of course I will keep getting this clash. The finishing of the second pockets, the counterbore hole looks okay, and of course for the perimeter of this part another clash. SolidCAM will stop the simulation and give me this message. I will stop for current operation. Okay, so I know right now I know what I have to do. I have to modify the fluid length of the tool, and then I will stop. I will not have all these messages. I will exit the simulation. Of course, let's see what else we have here. Let's try the G code for generate all the G code for all operation. So this is for Fanuc 3-axis part. Automatically open my part with NC extension file. We're using the notepad, which is good. Okay, I have here the spot drill. It's G82. Okay, the counterbore hole and the end of this post process. I have here I've seen here this nice, I don't know, nice function. It's called tool sheet. It will generate a setup sheet for the tool with a picture of the zero program. So mainly now a simple part. You have seen the workflow in SolidCAM. Now let's try this part also in CAMWorks. Okay, the same part in CAMWorks. So the workflow in CAMWorks it's a little bit different because the there are three new icons: feature tree, operation tree, and tool tree. All you have to do in the beginning, of course, define the machine. For every machine you can, and it is recommended to define a tool crib and a post processor, of course. CAMWorks when it is installed, comes with a 3-post processor for a generic Fanuc machine. Defining of course the stock, I will put the same values like in SolidCAM. I have here the ability to have uniform allowance on the 3 axes. Okay, and now I will not use the extract machinable features to recognize automatically all the pockets and holes and the perimeter, because CAMWorks can do this. I will insert it manually. So the working area, then the 2 axis, and now I will start with the face 2 axis feature. Type of feature, it's face. Starts from here up to stock. Okay, I define the feature. Now I can go to operation and define as a stock vertex, let's say this one, or maybe this one. You can browse to all vertex in CAMWorks on the stock. I will rotate with 180, and this is my 0 program. Okay, so for the face feature, for every type of feature in CAMWorks you have specific strategy that you can define. For a face feature, for example, for 2-axis mill operation, I will have a face mill. Okay, validate the selection, and now this is the operation parameters for a face mill. I will go to my tool crib. I can easily check and select a tool from here, but of course I can modify this one to be like this, or go to the tool crib, and here I have the tools, the general tools. I have of course a face mill. Let's select this one, face mill with diameter 40. The mill holder, the tool crib is the place where you can choose the tool from a tool crib or formula library. The station, feeds and speeds, step over control in facing parameters, step over the offsets. If you want to extend it, you have also here a group of options: the depth parameters, the direction control, the NC, the feature options if you need from technological reason to modify the machine in depth, leads and links, and so on. Cut method here, and generate a toolpath. So this is my toolpath. Generally CAMWorks is set for a mount with, let's say, 5 millimeters, one path, just like we did in SolidCAM. So I have one place for features, another place for operation. Here in CAMWorks feature tree, I will define the stock, the machine, and what I want to do. In operation tree, I will define for all the features the technology. Right now, I will define the perimeter of the part. The perimeter, it's a great feature in CAMWorks because you have two options, both as an open pocket. If you select the both, you have all the contouring operation. If you select an open pocket, you have a strategy like roughing, contouring, and so on. Because my allowance it's low on all sides, I will choose both, and for this I will have a contour mill, a phase mill, or a thread mill? Is it possible? And I will choose a contour mill with a tool diameter 20. If I remember correctly, I will change rapidly here. Feeds and speeds, contouring on side parameters. If you have the chamfer machining, rest machining, depth parameters, on the side parameters, you have here the ability to establish a previous allowance in order to have more passes on the X and Y direction. Of course, the corner for internal and external, the NC, the feature options, the entry and retract method, the machining depth if you want to modify the X segment offset, of course the lead in, lead out, arc, perpendicular and parallel, advanced posting and optimize. Let's generate also this operation. Looks good so far. Let's try and use and define the pockets. It's very easy. New right click on a mill part setup, new 2.5 axis feature pocket type, and just click on the 3 lower parts of these pockets and condition, and now I have 3 rectangular pockets defined. This one, and this one. Okay, for all rectangular pockets. Right now, to show you another good and very useful function, I will create a group from these pockets, from rectangular pocket, and 1, 2, or 3. You have the ability to create a group in order to have only one rough mill operation, but right now I will create a rough mill operation with this tool, generate. For the second one, I will create and copy all the parameter defaults from rough mill 1, the tool, and so on. And for the rough rectangular pocket 3, I will create the same steps. And right now I have the roughing operation for the 3 pockets. Let's combine this operation in one and then look at the rough mill. I have only one operation now. Let's look at the rough mill parameters. The tools, then feed and speed the same. For the roughing, as patterns, I have pocket in, pocket out, zig, zigzag, spiral in, spiral out, plunge rough, offset rough, and of course the volume mill. The cut angle, the depth parameters, side parameters, of course, cut method and depth processing, the NC tab, the same in all operations in CAMWorks, the entry and retract method, advanced posting, and optimize. Okay, the same procedure I will do it for finishing, for a contouring operation, the same like a profile operation in SolidCAM. Right click, contour mill, the same for all pockets, and of course the last pocket. Generate a toolpath. Let's change the tool, a smaller tool, like let's say diameter 10, lead in perpendicular, like in SolidCAM. Okay, and the tool parameters have changed. Change all the same operation with the same tool. Generate
and combine to have only one contour mill operation. Now the only thing I need to do right now is to define the hole. For the hole, I will show you a trick because I choose to use in SolidCAM the hole wizard recognition process. I will do the same in CAMWorks, so just CAMWorks NC Manager, options, mill features. I want for CAMWorks to recognize only the holes and non-holes, extract machinable features. Right now, non-holes means in some cases the rectangular pocket, it is recognized automatically. I'm not interested in this, but I'm interested in a counterbore hole. Generate. I have the same operation like the technology, just like in SolidCAM. And now the last part before the post-processing, of course, is a simulation, the facing, the roughing of the pockets, the finish of the pockets, the counterbore hole, and the exterior. Of course, a very powerful tool, which is the show difference, the comparison between machine and the 3D model. Everything looks good. The post process, the same, it opens up in Notepad. A Fanuc, let's look at the last operations. For drill, I have here 82, 83, drill, center drill, and so on. You have also the ability in CAMWorks to generate a setup sheet more clear with all the operation. You have some templates. Before this, I just want to tell you that this part can be made in seconds using automatic feature recognition. But I want to show you in this video the difference between SolidCAM and CAMWorks with a 2.5 axis part. Thank you for watching. Hope you have all the information you need in order for you to decide which is the best. And until next time, see you. Bye.